Welcome to the programming model. In this session, we'd like to talk about some of the basic programming elements that are available inside of OutSystems, and they've been separated into layers. So we'll look at some of the basic elements very quickly, and then take a deeper look at how they fit into the overall life cycle of the screens that we try to create. So there are web screens that have a particular type of life cycle, and it revolves around synchronous requests and responses. We also want to look at the mobile screen lifecycle and how different it is, and the fact that it's asynchronous, and then it has many more events and event handlers to dictate how the screens will be rendered and how they will be interacting. So, if we think about the OutSystems environment, we know that OutSystems had the capability of doing web apps in previous versions, and that's because it had the server-side logic and the synchronous request response that we were just talking about from a web app perspective. Now we have the new mobile applications, and the new mobile applications have client-side logic as well as available client-side local storage, and they make all of their requests in an asynchronous fashion because the device, once it gets its data, can change the way it looks and what it does as it needs to. So two very different programming models, or at least two different life cycles for those types of programming models. So when we think of the basic elements that OutSystems creates, we know that we've talked about the four layers. And when we think about the four layers, we can kind of leave business processes and processes alone because they're on a higher level. But if we think about the interfaces, we will have different types of screen flows or groups of screens and individual screens inside of those flows. And those screens and those flows can have some sort of themes to go ahead and dictate the overall look and feel. Those screens will eventually need to do something, and that requires some sort of logic. There will be client actions that run on the device for the mobile side of things, and then there are the server actions that are running on the server side. Sometimes when we're doing extra work on the server side, we will be using services or other types of integrations and making sure that those are secured. So a lot of different individual logic components that are available, and we're going to need some data. The logic and the screens will be attempting to display some sort of information, and that may be information that's been persisted inside of a database. It may be just information that we've built inside of the application and is in memory, but there are plenty of types of data that we wish to be able to expose inside of the apps that we're building. So if we think about the web apps that we may want to build or that we have traditionally built in the past, a web app is a page, so we may have some sort of HTML page and it makes a request. So maybe we're trying to book a hotel and we ask for more details about a particular booking. When the request comes to the server, OutSystems has these UI flows that we mentioned, and the UI flows have individual screens. So if we're looking for the booking detail screen, it can navigate to the booking detail screen and basically say this is what the booking detail screen is made up of, and here are some of the things that we can do inside of the screen. If we're just trying to get the screen, we would get the data that is required to prepare the overall HTML page, retrieving the things from the database that we need, and then looking at the screen itself and saying what are the widgets and individual UI components that need to be rendered. And we would go ahead and render those as HTML, send the data back, and any other cascading style sheets, JavaScript, any types of images that would go back as individual page resources. And that would allow us to return the page. So that's sort of one simple life cycle through the page. Now if we wanted to go ahead and then cancel a booking, we would again ask for cancel booking. When we cancel the booking to the detail page, instead of just running the normal page, it would go ahead and do the change booking status. And in changing the booking status, it would update the booking inside of the database, and then it could return more information to this page or somewhere else. But this is the type of lifecycle where we go over the different resources like the UI flows, the screens. Here we have the actions that are available, and then going into working with the entities in the database. So all the different layers are involved, all of them are related to each other, and they're all part of the overall lifecycle, mostly because we generally look at things from a presentation layer and view versus the data being the model, and the logic sort of being the thing that sort of combines them together in the middle. Now, when we begin to think about the new mobile apps that we wish to build, we want to see how that can potentially be different. From the highest level, it's important to understand that mobile apps aren't going to do that normal request response thing, because mobile apps are going to be single page applications. The OutSystems 10 compiler is going to generate JavaScript to take care of the screen logic on the client side. And that JavaScript will generate HTML and the ability to display the screens the way we want them to be displayed. Whenever those screens need data, they will request the data asynchronously, and OutSystems handles all of that by allowing the data to be exposed from the back end as a RESTful endpoint. And those asynchronous actions are not going to keep the screen from rendering. So if something needs to change on the screen or someone wants to navigate somewhere else, it is not blocked by the fact that we've made a request for data. And multiple requests for data can be in flight at the same time, and that can be helpful as well. So the logic inside of the screens is now specified as client actions instead of before anything we wanted as far as behavior in screens. We'd have to ask the server for help, and it would always be a server action. So there is an interesting difference there. So when we begin thinking about the new runtime architecture, we have this JavaScript set of code that's running, and it's running on the device in a model view controller type of way, where some of our data could be local. The overall view is being handled by the React JavaScript components, and there is a controller making sure that all of these things work together. And we can still have plugins and other types of things, but whenever we need data, we make very efficient REST calls back to the server to get the logic or the data that we need. So if we think about our mobile app and we were going to load it from the very start, we would get a splash screen to start. And the splash screen would say that it's loading all of the resources. In loading all of the resources, what it's really doing is talking to the server and getting all of the bits of JavaScript that it would need. And when we say it's getting all of the JavaScript, if we went into Chrome and DevTools and looked at the list of all of the JavaScript that's being downloaded, it would be all of the different little components that are needed, as well as the definitions of our app and all of the pages that might be available in the app. So if we thought about going to the to-do detail page, we can see that in the to-do app, the main flow has a to-do detail page, and that page has a model view and a controller. So this screen has capabilities to go ahead and run on the device, because those three parts of the JavaScript are all there to manage things while it's on the device without having to interact with the server at all. So once we now are in this new world where basically the splash screen can load and the whole app is on the device, other than the dynamic data that we need a new set of events and life cycles to go ahead and help us manage all of this. And that includes an application event lifecycle. So we need to know when the application is ready and is loaded. And anytime it's ready, that means that the user could eventually basically turn off the app, could basically put it away, and then we might, at some point when they open it again, need to resume it. So once they've closed it, resume will occur when they open it, and we need to be able to react to that. Once the app opens back up, it's going to open to some particular screen, and those screens have life cycles now. They know when they are initialized, when they have some of their information ready, when they've been rendered, and if and when we need to destroy them. And when we say that there are these lifecycle events, the events can occur, and when we have these on initialize is the event that we can get, and then we could go ahead and create some sort of action to say when we know we're at the initialization stage, is there something we'd like to do? So these are basically callback actions for us to be able to do something when these events in the life cycle occur. Now, that can be fairly important because we're also going to have screens that may have multiple components. So we've mentioned that blocks are available. We can either pick blocks that have been pre-built, or we can go ahead and build our own block. If we built our own date picker block, and inside that block the date changes, maybe that date from the block needs to go ahead and affect something else in the rest of the screen. So we need to be able to send that event back. And when a screen is using this date picker, it will have to specify a handler so it knows how to handle that event that can be thrown. So things are a little different in the fact that the screens will be potentially built up of all of these blocks. These blocks may need to communicate, and the blocks will probably need data, and the data is fetched on the screen level. So the screen will dictate what type of data it needs. Blocks could also have data inside of them, but all of that data is fetched asynchronously, and multiple sets of those requests could occur at the same time. So there's a lot going on inside of a particular screen. What would be the order, or why are these events important or necessary? So if we think about opening up an app and it begins loading the resources, there'll be a first screen, the default screen that we might need to go to. That screen will begin getting initialized, and in the initialization event, we could go ahead and decide to set up some default variables, some initial parameters that are important, and then as the screen is initialized, after that it would make any of the calls for data that it might need. So if this is the contact screen, it would say go get all the contacts, and for all of the people that are in our contacts, get their images. So after initialization, the requests for data occur, and then it begins loading up the page. And once the DOM is finished loading and the page is ready, we know that the DOM is ready, and we would be able to begin seeing something about the screen, because now that the DOM is ready, we could begin rendering the screen. Well, if we're ready to render the screen, but we don't have any of our data back yet, and our widgets and components need data to go ahead and be able to render themselves, we would probably want some sort of spinning wheel saying we're still loading the data. Once the contacts are back, if we needed to do anything to the contacts after we have fetched them, there's an on-after fetch event. And if we then have fetched the data and we have done any kind of adjustments to the data that we need, it would then automatically cause a render event. Because inside of the page itself, it knows that the contacts are one of the pieces of data that it needs, and when the data changes and is ready, then it will re-render the screen to go ahead and display that data. So at this point it renders the screen. It doesn't have the images, so it shows placeholders, and then it goes ahead and shows the contacts. Once the profile images come in, if we need to do anything on after fetch, we can do that, and then it renders and it adds the pictures. So you can see here that at different stages as the screen is progressing in being able to have all the resources it needs and being able to display the pictures, these events and parts of the life cycle are much more important with the way things will progress and continue forward. So these lifecycle event handlers are fairly specific. On initialize allows us to go ahead and basically do work once we know that yes, person who's navigating to this screen has permission to get to this screen, and if we need to do any initialization like settings or default information, we can go ahead and set that. On ready, as I mentioned, will occur once the screens and the blocks DOM is ready, and that way you can manipulate the DOM if you need to. On render occurs right after on ready, or on render can occur when any time the data inside the screen changes. So in this particular case, the on render is available to kind of always keep the screen reactive so that as data updates, the screen updates as well. On after fetch is available for any of our fetching of data, and we can then go ahead and use it to act upon the data that's been retrieved and potentially change it a little bit before we need to display it. There's another event that we haven't introduced yet, but we'll talk about in a second, which is on parameter changed. And this means that if a parent passed in information to a child block, and that block's input needs to change because it changed in the parent screen, it would go ahead and submit that change to the block itself. And that way the block can react to the input that may have changed. And at the end there's an onDestroy, and that just says that whenever the screen and block is done, we may want to be able to do some work to clean things up before it is actually destroyed. So that can be important. Now, we looked at loading a screen kind of from scratch from the very beginning, but what happens if we're on a screen and then we go ahead and ask to go to a new screen? So if we click on one of our contacts, we'd like to go to the contact details screen. The contact details screen begins becoming initialized, and the event for destroying our current contacts page is thrown as well. So we understand that this is going to be destroyed. We start initializing the next page, and in initializing it, it will go out and say, okay, given that you've selected one of these contacts, let's get that contact information by ID. So we'll make the data request, and then we'll actually get back the ability to have the screen be ready. So it's been initialized, the data's been kicked off. Once the DOM is ready, the screen is ready to be rendered, and at this point, if we have said that between this particular screen and the new destination there is a screen transition, that screen transition will occur. So that could be a slide left, slide right, fade in, lots of different screen transitions. And once it transitions to the new screen, then the new screen is available and can be seen. So even while the destroy, the initialize, the onReady, and the beginning of the render occurs, none of this is actually seen. The user is still seeing the old screen. And then once the onRender has occurred, the screen transition will occur so that they'll be able to see the data, and once the request for the fetched data has returned, it will go ahead and update and show all of that data as well. So again, slightly different order and way in which the events occur, but it's helpful to understand how some of this can affect what you're seeing, because it's not the normal life cycle that we might be used to. And then the last one here is what happens when we change the parameters of a block. And when we change the parameters of a block by saying maybe there's a date and we're viewing some data for a particular date, if we go in and change the date, then the date has changed in the screen. We need to change the block's data and tell it that it should render itself given the new date that was the input that allowed it to draw the first graph. So once the date has changed, parameter change event occurs, and the block is basically told you now need to react to the parameter that has changed. It begins doing that, and it may need to refresh its expense data. So as it begins refreshing its expense data, and that takes a little time, it will go ahead and render, but it will still have the same information that it had before, so it's rendering the same look of the graph and nothing changes. Once the new data comes back, then it will render and change the change both the block for the data that's there, and the overall screen renders now that the block has changed as well. So we'll be able to see the new page and what has changed. So these three different types of asynchronous life cycles and events and handlers can really change the way we're going to be thinking about things and using the fundamental programming blocks and the fundamental programming elements that we need. So hopefully this has given you a quick introduction. You can check the documentation for more details on this, and we'll be using these a number of times inside of our exercises.